Hey everyone and welcome back. Today I'm here with another fascinating math problem, and this time we are diving into the topic of the greatest integer function. Let's read the question. How many integers are in the range of the function y is equal to x minus 9/4 of the floor of 4/9 of x? Okay, so to tackle this problem, I'm going to show you two different methods. The first method is more straightforward and gives us the answer from a broader perspective. So let's start with that one. Alright, in the first method, I'm going to start by changing the expression inside the greatest integer function. And so I'll use the substitution method. So I'll set 4/9 of x equal to u. If 4/9 of x is equal to u, then it follows that the x itself is equal to 9/4 of u. So the general form of our function changes to this. Y is equal to, instead of x, I put this one. 9/4 of u minus 9/4 of the floor of u. Okay, now it's pretty clear that we can factor out a 9/4 and see the function like this. That y is equal to 9/4 of u minus the floor of u. Now, as you probably know, u minus the greatest integer of u is just the fractional part of the number u. Therefore, u minus the floor of u is always greater than or equal to 0 and less than 1. So we can write that u minus the floor of u is greater than or equal to 0 and less than 1. Okay, now all I have to do is multiply this inequality by 9/4, which gives us this. So I'm going to multiply this inequality by 9/4. So we have this inequality. I'm sorry, it's u Okay, and this expression right in the middle is our exact function y. I mean this one. So we have y greater than or equal to 0 and less than 9/4. So the value of our function is between 0 inclusive and 9/4 exclusive. And within this interval, the possible integer values are this one: 0, 1, and 2. Okay, which are exactly what the question asks for. Alright, let's move on to the second method. This one isn't quite as straightforward as the last one, but it really takes us into the heart of the matter. In this method, I'll start with the reasoning that the output of a greatest integer function is always an integer, regardless of what's inside it. So I'm going to set the greatest integer of 4/9 of x equal to m, where m is an integer. So we have this. The floor of 4/9 of x is equal to m, where m belongs to the integer set. Now, according to the definition of the greatest integer function, I can say that 4/9 of x is greater than or equal to m and less than m plus 1. And if I multiply this entire inequality by 9/4, I get this. 9/4 of m, I'm sorry, x 9/4 of m plus 9/4. Now let's rewrite our function y one more time. Since we set the floor of 4/9 of x equal to m, we get this, that y is equal to x minus 9/4 of m. It's very clear that if you plug in the start of our interval, which is 9/4 of m, in place of x, the result is 0. So you can see that if x is equal to 9/4 of m, so y is equal to 0. Now, if you move 1 unit forward from the start of the interval, meaning that x is equal to 9/4 of m plus 1, then you can see that y is equal to 1. Okay, if you go 1 more unit forward and set x is equal to 9/4 of m plus 2, then you can see that the result becomes 2. But from here, you can't advance by another full unit or more, because if you do, you'll go outside of our defined interval for x. This is our defined interval for x. Also, for any other value of x in this interval that isn't in the form of 9/4 of m plus an integer, the output y will not be an integer. So all in all, this function has 3 possible integer outputs: 0, 1, and 2. Alright, I hope you enjoyed solving this problem. Stay tuned because I'll be back in future videos with even more awesome and challenging problems. But for now, goodbye.